Hello and welcome to the next video of Python for Data Science by Utkarsh Minds. Today we will see for ordinal data how can we apply a hypothesis test and solve research questions. So this will be in Python. For that again I will type in my browser collab.research.google.com. This will open the Colab notebook. Here I am creating my new notebook. Once the new notebook is open, I can give it a name. I will call it ordinal data testing, and I will click on connect. Then I will also upload our data set here. So for uploading the data set, I will upload GSS 2012A. Then I will write the basic steps to read the data set. So data is pandas dot read CSV. Here I will write GSS 2012A.csv. So this will read my data in memory. Then I am selecting one ordinal data column from this. So this entire data set I don't need. I will only need a single column from that data set, which is named as ACCNT SCI. And I can also apply value counts to show you how is this appearing in my results. So the data set is still not uploaded. We will wait for it to upload before applying this method. Okay, so now the data set is uploaded. I am running. I can see that in the column there are 4 options, 4 values: not too scientific, not scientific at all, pretty scientific, and very scientific. These options are examples of ordinal data. The reason is they can be arranged in an order. You can see that the option not scientific at all comes at the lowest part. Further, there is the option not too scientific, then pretty scientific, and then comes very scientific. The first thing that we will have to do is replace these with numbers or replace them with code. So in this ordinal data, I will apply my function replace, and I will replace these words, these 4 words, not too scientific. These are the different words. I can write here value counts dot index. It will give me the list of these. So here I have the list. I am pasting it here. Not too scientific is level 1. Not scientific at all is the lowest level. I am calling it level 0. Then pretty scientific is level 2, and finally we have very scientific as the level 3 or final level. Okay, that is how these ordinal fields have to be arranged. I am writing here the names of the 4 fields so that they are clear to you. This is level 1, this is the lowest, level 0, this is 2, and this is 3. Ideally they should be arranged in this order. So once these are arranged, you can see that we will replace them. Once I have replaced, then only I can use the functions for hypothesis testing. So the hypothesis test is working on a research question. The research question is the median value of the data is equal to x. Okay, x is some hypothetical value. So I will call it hypothetical median, and that is the question. So there is the null hypothesis and there is the alternate hypothesis. From this research question we can derive the two hypotheses, null and alternate, is not different, okay, from x, and the second is that it is different from x. If it is different, so if the p value is less than 0.05 and we can say that it is different, that means the null hypothesis is rejected, the next part will be to find out the effect size. That will tell us how much is the difference, small, medium, large or negligible. So negligible, small, medium and large. These are the usual difference magnitudes. Next comes, once we know this difference, we will be applying the test for hypothesis testing, finding out which of these hypotheses is correct. For that we will go to SciPy stats and import the test named Wilcoxon. This is the Wilcoxon test. In this Wilcoxon test, once we get our library, we will have some hypothetical mean, I will call it 2.5, and then I will apply the Wilcoxon test on ordinal data. So the test will use a function here, zero method, which is Wilcox. Once the test is completed, we will get the p value, which is because there are some null values here, the test has come as not a number. What we will do is, we will remove the null values first, that means ordinal data is equal to ordinal data drop. Once I do this, that means I am deleting all the null values or missing values, and then only I am calculating the test statistics. So the p value that I am getting is 8.37, which is very less than 0.5. That means the null hypothesis can be safely rejected and the alternate hypothesis is most probably true. That is how this test can be completed. So we have seen the test Wilcoxon, which aims to find out whether the alternate hypothesis or null hypothesis is correct. From the sample, we are inferring about the population. So I will add the word population here, because we are working on a sample, and because the p value is less than 0.5, we can say that even the population is following this inference, that the median value of the population is different from x. Very useful test. You can write the report, the final report will look something like this. You can say the median of the population does not find accounting as scientific or some conclusion like this, because the median is not equal to 2.5. Whether it is less than or more than is not a part of our question, because we are using the two-sided test, which is non-directional. It only checks whether the difference is greater or lesser. Difference is there, but not whether it is greater or lesser than the median. So that was the Wilcoxon test, and we will see how to calculate the effect size for this test in the next video.